Good day, everyone. Welcome to my lesson. I go by the name of Tulani Kelvin, the tutor. So today we are going to be looking at grade 11 mathematics. We are going to be proceeding with the last topic that we were busy with, the last chapter. We were busy with financial mathematics. I did the first video as well as the second video. I believe this one is my last video. I'm closing the chapter, financial mathematics. So today I'm going to be presenting the nominal and effective rate interest. So we are going to be looking at those two topics. I can say that they are simple as the previous concept that I did present for you guys. So there's nothing to worry about. So I'm referring to from Mind Action series, mathematics grade 11 textbook and workbook. So you can practice using this book. Is prescribed for learners actually. So it's the best textbook we have ever had. Financial mathematics. Let me just say 290. 295. So we are going to be looking at a nominal and effective interest rate. So a nominal interest rate is an annual rate which financially institution quite. This interest rate does not take into consideration the effective of the different compounding periods, which are shorter than an annual period. For example, 50% per annum compounded monthly is a nominal rate. The annual rate is 15%, but the fact that the interest is compounded monthly means that the accumulated amount of the end will be higher. Obviously, you know that if you are receiving an interest monthly compared to annually, obviously if you are receiving it monthly, you are going to accumulate more money compared to annual, you understand? So those are the things that you must know. The quiet annual rate of 15% will yield a lower accumulated amount than 15% compounded monthly. So annually will be less and then monthly will be high. So those are basically the basic things that you must know about this topic here. Effective interest rate. Annual effective interest rate are therefore the equivalent annual rate that yield the same accumulated amount as rates with different compounding periods. Annual effective rates are higher than the quiet nominal rates. We refer the annual effective rate by means of the notation IFF, the IFFF. If the interest rate is quoted as a 18% annum compounded monthly, we have a nominal rate because the quiet period and the compounding period are different. However, if the interest is 18%, you just divide it by 12, it's going to give you 1.2 per, if this thing is compounded monthly, you understand? So here they were just trying to explain for you what is the effective rate, the effective interest rate as well as the nominal interest rate. But those two keys or concepts, they won't say define what is the interest or what is the effective and the nominal interest rate. I don't remember our examiners asking that question, so I think that is not going to be useful, but the calculations are going to be useful for you. So let's quickly jump into the board. Let's quickly jump into the board and check exactly. Let me introduce the formula for you. So the formula that we are going to be using for this concept is going to be 1 plus the I effective is equal to 1 plus I norm over n to the exponent n. So in this case, this symbol here or the letter, it represents the effective rate. Effective interest rate. Effective interest rate. Sorry for not writing it that in full. I believe that you can hear me very well. And then this one here is a nominal. Nominal. Oops. Nominal. Let me just. Nominal interest rate. I'm lazy to erase the nominal interest rate. You understand? So this is the formula that this formula is important for you. You must know it. So let me just go there in the board. You see, I of effective there is it represents the effective rate annually, and then the I norm it represents the nominal rate, and the N is the number of compounding. Yes, you understand. So this formula is important, and you must know it because of you are going to be using it throughout this concept. So I suggest that you must know it. Okay, let me just take one example here, so that the basic example. So they say convert a nominal rate of 18% per annum compounded monthly to an effective rate. So in this case, we are given a nominal rate of 18% per annum compounded monthly, and we have to convert this to the annual effective rate. You understand? So we have the 18%. Okay, let me just clean my board. We have the 18% of the nominal. Let me just say I norm is equals to 18%. And we have to convert it to I effective using the formula. So don't forget, we want this in decimals, you understand? So we are just going to divide this by 100 so that we can have something like 0.18 when we divide it by 100. You understand? So lastly, what we are going to do, we are just going to copy our equation. Our equation as it is going to be 1 plus I of effective is equal to 1 plus I norm over n to the exponent n. So therefore, let's go back to the statement. They say convert a nominal interest rate of 18% per annum compounded monthly. So let's go to the board. We know that this thing is compounded monthly, and then we are having the nominal interest. So therefore, since this is 0.18, what we did on the previous lessons, when it's compounded monthly, we just divide it by the number of months. Monthly is 12 months in a year. I guess you already know that. Is 12 equal sign 1 plus I effective. So in this case, what you should do, you can just punch this on your right hand side. Well, when I look at this, it's on my right. I don't know about you there. Maybe it will be on your left, but I hope it's going to be on the right. So let me just do this. You can punch this on your calculator, and then when you punch this on your calculator, what you're going to do, you're going to get your answer here. Okay, let me just not be lazy. Let me just punch this on the calculator. So my answer for here on my right hand side is 1,196, and we also have the one there. So what's going to happen, I'm just going to transpose this one to the other side of the brackets, meaning to the right hand side there. So therefore, well, let me just minus 1 minus 1. The I effective is 0 comma 1 5 195 6. Let me just leave it like this: 195 like 5 6. And then you can also, since they want you to convert this into the effective rate, we want the percentage, you just multiply it by 100 here. I recommend that, actually I suggest that you should not cancel your answer on your calculator, you understand. Even now I'm having my answer. Unfortunately, I cannot show you this on my calculator. I should get a Casio for that supports this system here, the Windows system. So I should get it, because in finance, actually, you must go with your answer. You must not see yourself canceling your answers, you understand. So the percentage here is 19,56. 19,56. So in this case, even if like maybe you round off to 4 5 decimal places, you stand a chance to get the correct answer there, you understand. So, but the best way is to store or not cancel your answer, you understand. Store or not cancel your answers. Unfortunately, my learners know that, because of I I show them how to store, you understand. So, but if you are having any questions on how to store, you can just hit me on my social media platforms there: YouTube, Facebook. That's where I'm available for now. But I just hope later, as time goes by, we will be available in Instagram, Twitter, you know. Anyway, let me just proceed with the lesson. Uh, so as we proceed with our, as we proceed with our lesson, um, we are just going to be, actually I'm going to do number 3 from exercise 4 here, where Tamara invests 24,000 at 14% per annum compounded quarterly for a period of 12 years. So they say calculate the future value. Calculate the future value of the investment using a nominal rate. So let me just quickly go to the board and collect data. I can say data is the information that we are given there. So the investment is 24,000, and then at what interest? At 14% compounded quarterly. Let me say R is 14%, and then they are talking about something quarterly. Let me just represent it with 1/4. You understand? I believe you understand 1/4. You understand? So as we proceed, what else for 12 years? Okay, N is 12 years. And okay, now it's time for us to calculate. Let's see the investment of, this is number 1, where number 1 from here, from number 3. So let me just present it as A as they did in the book. Let me just say A. So the A, they say calculate the future value of the investment using a nominal rate. So this one is straightforward, a nominal rate. So is A is equal to P 1 plus I to the exponent I. So N. So they want the future value, so meaning the accumulated value A. So we have 24,000 as the invested amount, 24,000 as the invested amount there. And we are also given the percentage, but you know that we must convert this percentage to decimals. You understand? 14% there divided by 100. You already know that. My learners know that. So let's substitute our data there. So you remember what did they tell you on the statement? Let's just go back again. They said that 14% annum compounded quarterly for a period of 12 years. So let's go to the board. So this thing, since is compounded way, what quarterly, we just divide it by 4, and then it's 12 years, right? We're just going to say 12 multiplied by 4, and from here you just punch your calculator, you'll get your correct answer. So my answer here is, let me see, 125,126 rand. 125,126.1. Let's round it off to 2 decimal places. 14. So this is your answer for A. This is your answer for A, is Tamara Investments. It's not bad, it's not bad. Oops, sorry. So as we proceed with our lesson, let's go for number B. They say convert the nominal rate of 14% per annum compounded quarterly to the equivalent effective rate. So we are converting a nominal rate of 14% per annum. We already know is compounded quarterly. So to the equivalent effective rate. So we are going to be using the formula that I did introduce in the first, at the beginning of the lesson. So I guess you copied this somewhere else in your scribbler or on a page, I don't know. Or if you don't copy, maybe you are good at just listening. So I will just erase this. Before I erase this, let me just copy this answer, or let me just store this answer on my calculator, so that when I store this, eventually I will be teaching you how to store. But the problem is that you won't be looking at your I won't be showing you on the screen here. I will just announce the steps as I store this. So first thing, you just press shift on your calculator. You press shift, and there is a button that wrote RCL, something like that, and then on top of that button there is a store written in yellow. You just press the store, and then from there you can select the alphabets where you can store, where you want to store your answers, you understand. So on top of that RCL button, you are having another button. If you can check, there are alphabets on top there. They are written in a reddish color. Is A, B, C, D, E, F, and then followed by, at the bottom there is X, Y, M. So let me just select A, where I want to store my answer, and then if you have another answer that you want to store at, you want to store your answer, again you can select B, because of you already chose A, you understand. So let me just proceed with my lesson. I did store my answer. If I'm going to need it in future, I will just represent it as A there. So let me just proceed. So I should convert this this nominal rate to the effective rate. Okay, so let me erase here. I don't want to erase my data there because I believe it's going to be helping me a lot. Unfortunately I don't have enough space here, so let's go for B. First things first, let's copy our formula. 1 plus I effective is equal to 1 plus I norm over n there. So there you go, just substitute your answer. So let me just go your data there. So let me just go convert the nominal rate of 14% per annum. So you are converting this nominal rate of 14% per annum. So let me just say let me substitute my data there. So I'm having 14% of a nominal rate there, so it's going to be 0.14. You know how to convert the percentage to decimals, so we are just going to divide it by 4, since is quarterly. That's the statement. Convert the nominal rate of 14% per annum compounded quarterly to the equivalent effective rate at effective rate annually. So it's easy to do this, guys. So we substitute our 4 days since it's quarterly, and then it's 1 plus the I effective. So like the first example that I did present for you guys, you punch this on your calculator, and then another thing that you are going to do, you're just going to transpose this 1 to the other side of the equal signs, or you are going to transpose it to the right hand side. So it's going to be negative. If you transpose that, you already know that. So let me just punch this on my calculator and get my answer here. So my answer here is 1.1475. Let's round it off to 4 decimal places, and then I'm having, remember, you are going to transpose this 1 to the other sides of the equal signs. So let me just, when I transpose it, it's going to be -1, and then my answer here, let me just minus 1 here, and I get 0.1475, and therefore you just multiply this by 100 so that you can get your answers in percentage. So let me just multiply this by 100, and I get my answer as 14.75%. Let me just leave it like that. So let's proceed to number C. Use the annual effective rate to show that the same accumulated amount will be obtained when using a nominal rate. So we are just going to be using the annual effective rate to show that the same accumulated amount will be obtained when using a nominal rate. So let's go back to number A. We were using a nominal rate there to calculate the future value. So in number C, we are just going to be using the annual effective rate. You understand? Annual effective rate. So let's just use that the answer that we got here, so that we can see whether we are going to accumulate it. We are going to accumulate the same amount obtained at A. So in this case, let me just try to write this somewhere here, and I'm also going to store my answer for this percentage here. Let me store this answer at B. Let me shift RCL there, store at B. Now I'm having two answers, B, and then just in case if anything happens, because of I'm dealing with financial maths, guys. The decimals are important. Imagine you are working at the bank, you are calculating somebody's money who invested, and you just do a mistake with a decimal. You're going to get fired. You can tolerate that. So make sure, guys, you be accurate. Let me use a black mark. So number C, I copy my equation there, my formula, equation. So, well, we are having P there as the invested amount is 24,000 and 1 plus the interest. Now since we are using a, let's go back there, we are using use the annual effective rate to show that the same accumulated amount will be obtained when using the nominal rate. You understand? So we are going to be using an annual effective rate that we just converted to okay, let's just, meaning this is our percentage here, so just divide this by 100. Actually, this is the percentage that we must substitute here, you understand? So let me just say 0.1475. You just divide it by let me see, it was quarterly, right? Divided by 4, and the number of years does not change, so it's going to be 12 multiplied by 4. Let me just say 12 multiplied by 4, I get 48. So the number of years there is 48. I'm sorry, here is 48. So I think I'm having everything here. So let me just punch this on my calculator and just get the correct answer there. So the answer for number C is going to be let me see this, 125,126.136. So the answer for let's just go for let's go back to number A. According to the answer that I stored, I got my answer for number A. I'm not sure if I'm right or wrong. I got the answer as 136,519.349. So, but these two answers are not the same. So, I want to go back on number A. Let me just do number A again, because of this answer should be the same. I also, let me just do this. We are having answers here. So on exercise 4, number 3, here is the answer for A, and then this is the answer for B, this is the answer for C. Well, for the answer for C is correct, we can just round it off to 2 decimal places there instead of 3. So let me see number B. My number B, I got my answer is 14.75%. So let's see, there B is 14.75, 14.78. So we can simply round this to is correct, you understand? The reason, the problem there, I was just using I was converting, actually I was converting to two decimal, I was rounding off to two decimal places. So number A, let me just recalculate it, because what I see here, I don't know, maybe I did a mistake when I was storing my answer there. So A is going to be the accumulated value there, I mean the invested value is 24,000. Oops, but I don't have enough space here. I don't have enough space. So let me just try to create some space. Okay, A is equals to 24,000 1 plus the interest there. The interest, it was 14%. 14% is 0.14 divided by 4 is quarterly, and then therefore we are just going to say 48. 48 is not going to change, it is 12 years multiplied by 4, that's why I got 48. And then let me just punch this on my calculator now. Get my answer is 125, 125, 125, 126.136. So this is correct. Maybe I did some of the mistakes there when I was storing. I don't know. The problem is that I'm in the middle of the video. I cannot reverse it and check, you understand? But you can reverse it and check there. I will reverse it when I'm done with the video here. So basically this topic was my final video for financial maths, guys. So I guess this video was helpful for you, you know. So I just hope it was helpful for you. We can just I did number 3 for you. You can do number 4. You can also do number 1 there if you want to understand it much better, you know. So it's easy. So the last thing that is left here is calculations involving changing in interest rate. I don't think it can be useful, but you have to use a timeline here, you understand, as easy as it is. So there it is, guys. You can just simply go here on these examples, finding P, you know. I don't think it's difficult for you guys. So additional payments and withdrawals, you know. So let's say somebody was investing 2,000 for 3 years, and on that investment she or he decide to increase the money that he or she invested, you understand. So automatically you're just going to add that amount, or if she or he decide to withdraw that amount, you can you will minus that you understand. So but if you are having any difficulties, don't hesitate to comment, to leave your comment, you know. So I will be there for you. So this is the last video for this topic, but any questions or anything that you feel is difficult for you, you can just leave your comment here on YouTube, or you can just leave your comment on my email, tulanikelvinmasugu@gmail.com. Thank you for watching this video. I guess we will meet on the next video. Don't forget to share and like, also to subscribe on my channel. Thank you.